How to avoid exposing my MAC address when using IPv6? On my Macs, each IPv6 address includes the MAC address of a specific computer, not of my router. Sites such as ipv6test.com not only show it, but even tell me it belongs to an Apple computer. This feels like a super cookie, and might apply to other operating systems as well. How can I avoid my MAC addresses from being exposed? Background: the MAC address is not in plain sight. Like for 2001 column 0 db8 column 1 column 2 column 60 column 8 ff column fa52 column f9 d8. Take the last 64 bits, the host identifier, and add leading zeros, 0060 column 08 ff column fa52 column f9 d8. Strip the ff column fa part from the middle. If these bytes are not there, then there's no MAC address. For the first byte, complement the second low-order bit, the universal/local bit. If the bit is a 1, make it 0, and if it is a 0, make it 1. So, 0 by 00, 00000000 becomes 0 by 02, 00000010. Presto, 60 column 8 ff column fa52 column f9 d8 translates back to MAC address 02 column 60 column 08 column 52 column f9 column d8. Note: since macOS 10.12 Sierra, according to Ars Technica, Apple has adopted a new way of generating stable addresses that are not based on a MAC address, which Windows apparently had already been doing for years. This question was a super user question of the week. Read the blog entry for more details or contribute to the blog yourself.
This is solved by two extensions to IPv6. RFC 4941 aka privacy addressing lets outbound connections use temporary, randomly generated addresses, which are rotated every few hours. RFC 7217 allows the primary, static address to be generated from an opaque hash which does not reveal any information. At least one but increasingly both methods are supported by popular operating systems. Note that these features are orthogonal. You can use both at the same time, if you want to. Stable private addresses. In some operating systems, the primary interface identifier is no longer generated from MAC or UE64, instead it is generated using a hash or random seed, usually according to RFC 7217. This kind of address is still static per network. The same OS on the same machine within the same IPv6 prefix should always generate the same suffix. It is suitable for incoming connections. Windows beginning with Windows Vista uses a custom scheme. To check if the feature is active, run a PowerShell command. To enable/disable the feature. This can also be done using Network Interface IPv6. Network Manager on Linux supports RFC 7217 starting with NMV 1.2.0, using the connection profiles you would as part of the seed. This feature is active by default in recent NM versions. To enable or disable this feature, Systemd Network kind of supports RFC 7217 using this network file option, but appears to require you to explicitly list network prefixes for which this mode should be used. If no prefixes match, it will still fall back to UE64 method. DHCP-CD on Linux/BSD supports RFC 7217 using this option in /etc/dhcpcd.conference. To disable this feature and use traditional UE64 identifiers. Linux kernel Slack supports RFC 7217 as of Linux v4.1.0, however, it must be manually activated by storing the secret seed via sysctl. The secret key is a 128-bit hexadecimal string, shaped like an IPv6 address, which you can generate using. This secret key must be stored in the net.ipv6.conference.default.stable_secret sysctl. To make it persistent, it could be put in /etc/sysctl.d/50rfc7217.conference, or similar file. Setting the secret automatically activates this mode for all network interfaces. To check whether the feature is active, look for a Dirgen mode stable_secret in ipd-link, or the value 2 in sysctl.net.ipv6.conference.ifname.address_gen_mode. Temporary private addresses. This feature, defined in RFC 4941, provides additional addresses which are generated randomly and rotated every few hours. These addresses are used for outgoing connections only. You still retain your MAC-based or RFC 7217-based primary address for incoming connections. Windows supports temporary addresses as of Windows XP SV2. To enable/disable this feature, note that Windows now supports hash-based primary address generation starting with Vista, so this feature isn't as critical. Network Manager on Linux. Recent versions of Network Manager handle RAW on their own, although the two values below have identical meanings to sysctl. 2 equals prefer privacy address, 1 equals prefer main address. Note that Network Manager now supports RFC 7217-based primary address generation starting with v1.2.0, so this feature isn't as important. Side note, as of 1.4.0, NM allows randomizing the MAC address itself, to set Wi-Fi.cloned MAC address to stable to have a different MAC for every network, recommended, or random to randomize it for every connection, may cause problems. In all cases, name must be the connection name, for example Wi-Fi SSID or wired connection 1. Use icon to list all. To make this the default for new connections, as of 1.2.0 you can change /etc/networkmanager/networkmanager.conference. DHCP-CD supports temporary address using the /temporary suboption, or Linux kernel Slack supports temporary addresses, but does not use them by default. They can be activated by setting these sysctls. The all or default part can be replaced with a specific interface name, for example, net.ip6.conference.f0.use_temperature. I used IP link set F0 down and IP link set F0 up to force an address assignment, but you can also run disk6 F0 or just wait a few minutes for the next periodic router advertisement. Mac OS X, enabled by default since OS X 10.7 Lion. Temporary addresses, if enabled, will be preferred. Freezed. Older NetBSD versions. Latest NetBSD appears to no longer have kernel / support, in which case follow DHCP-CD instructions instead. OpenBSD support added in 5.2, enabled and preferred by default in 5.3. IPconfig shows autoconf privacy next to temporary addresses. Notes on configuration. On Linux, OS X, and all BSDS, edit, /etc/sysctl.conference, to make the setting permanent. On Windows, the changes will persist automatically. You can append store equals active to the netsh command if you want it to only last until reboot. Partially based on IPv6 operating systems at ip6int.net. See also General IPv6 notes. If the hardware address is used in the IPv6 address, it usually means your network uses IPv6 stateless auto-configuration. In such case, you can simply pick your own address suffix and configure IPv6 manually. However, even though the manually added address will not have your hardware info, it will still be static, unlike with privacy addressing, which changes addresses every so often. Also, static addresses can be a pain in a network larger than 2 to 3 devices.
FYI, this only applies to certain IP addressing schemes. More than likely you, or your ISP, are using IPv6 auto-configuration, which requires a fairly large block of IPs to accomplish in the first place. The solution could be to turn this feature off. Your ISP might use DHCP to assign addresses as well, which is still possible with IPv6.
If you want to